Okay, so today we're going to continue with chapter 10. We're going to find lengths of segments in circles. So we've been seeing a lot of arc measures. Now we're going to be finding lengths of segments. So here is our first thing, and it's a segments of chords. So when two chords intersect in the interior of a circle, each chord is divided into two segments called segments of the chord. So here are our chords. And this little piece here from A to E is a segment of a chord. And then from E to B is another segment of a chord. And then you could say a segment from D to E, and then also from E to C. So there's 4 smaller segments of the chord in this picture. Each one is a segment. Okay, so next, theorem 10.14. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. Now, I'm not saying here that the chords are congruent or equal in length. I'm saying their products are equal. So again, you're doing AM multiplied with MC, and then DM multiplied with MB, and their products are going to be equal. Now we're going to see tangents and secants. A secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of a secant segment that is outside the circle is called an external segment. So we have the entire secant, but then we've got the secant segment, and then we also have a tangent segment. Remember, the secant passes through the circle. The tangent hits it at one point, but they have the common endpoint outside. Theorem 10.15, segments of secants theorem. If two secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segment and its external segment. So we're going to be multiplying the whole secant segment times the external. So here they've shown us what it is. So the whole segment on this one is PN or NP, and then the external segment would be the NO or the ON. So this is the external, and then the red is the whole. And then over here, the whole is LN, and the external is MN. So we're multiplying the whole segment times the external on both sides, on both of the secants. Theorem 10.16, segments of secants and tangents theorem. So now we're going to have a tangent line and a secant line. So if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So we have our tangent segment, which is here, and it's going to be the amount squared. Then we have our secant segment, where we're going to multiply the whole times the external. So that's the external, this is the whole, and then this is our tangent here. And it's squared. This is where the factoring is going to be coming in, because we're dealing with a quantity that's going to be squared. So we've seen 3 theorems. You're going to need to know them and how to apply them. And we're going to see how to apply them on the next 2 slides. Okay, let's look at some examples. Let me zoom in here to A. So this was the first theorem we saw, and this is where you were the segment of the chords, the products were equal. So I have a chord here going across this way, and then I have another chord going across this way. So I'm going to take each one of the segments and I'm going to multiply them. So for the green, I'll do 3 times x, and for the blue, it's going to be equal to 2 times 12. So 3x equals 24. Divide by 3. And my value of x is 8. So notice if I put x equals 8 here in my picture, 3 times 8 is 24, and 2 times 12 is 24. So their products are equal. Notice the measurement of this chord would be 14, and the measurement of this chord would be 11. So again, the chord lengths are not equal, but their products are. Everybody good on A? Let's look at B. Okay, we have a secant segment and a tangent segment. So for this formula, we are going to do the tangent squared is equal to whole times the external, so the ext. So we're going to multiply those two. All right, so my tangent is right here. It's the x. So I'm going to do x squared. Then my secant, I need to find the whole length. So I'm going to do 18 plus 6. And I'm going to find out that that's 24. So I'm going to multiply 24 times the external piece. 24 times 6 gives me 144. Remember to solve for x squared. I'm going to square root both sides. And it's plus minus. So once I do this, I get x equals 12 or negative 12. However, I can't have a negative segment length, so I'm throwing out this answer. So my only answer here is x equals 12. So when you go to try to plug it back in to see if it makes sense, if you end up with a negative segment length, throw that out. Yes. All right, C and D, ready? Anybody still need B? Okay, let's go to the next slide. Okay, here we have 2 secant segments. Again, we need to do the whole times the external on both. So our formula here that we're going to use is whole times external of 1 secant segment, and then whole times external of the other secant segment. Again, I need to get totals here. So I actually have 8 plus 4. So my whole length here is 12. And then my whole length here on this one, let me do it in a different color, I'll do it in green, is going to be x plus 6. So I'm going to take whole of the yellow times the external piece, and then I have whole times the external piece. So I have to distribute and multiply the yellow. So the yellow becomes 48. The green becomes 6x plus 36. So I'm going to group my like terms so I can get x by itself. So I will move the 36 over. You could have put the green on the left. It doesn't really matter. And then I get 12 equals 6x. Divide by 6, and x equals 2. Everybody good on C? Next one, we have a tangent and a secant on part D. We're going to do tangent squared is equal to whole times external. Anybody need C still? All right, let's look at D. So here we're using tangent squared equals whole times external. Okay, so my tangent is 10. Actually, I'll set it up. I'll do the other side first. Let me do this side first. So whole is going to be 2x plus x, which is going to give me 3x. So 3x times the external piece, which is x, is equal to 10 squared. So now I get 3x squared is equal to 100. I'm dividing by 3. X squared equals 100 over 3. To solve for x, we have to square root it. And this is plus minus. So I could actually square root the 100. So the 100 turns into 10 over square root 3. I can't leave a radical in the bottom of my fraction. I have to rationalize by multiplying the top and the bottom by square root 3, leaving me with plus or minus 10 square root 3 over 3. That's your answer. Now I'm going to make up another problem to show you when you might have to factor. I think I'm going to leave most of the questions on the test like these examples that were in the notes. However, in the homework, you might encounter a question that's going to look like this. So if I were to add a circle here, and let's see. So I have a circle, and then I'm going to draw in some secants. So if I drew in some secants here, and they're meeting at this point, and let's say this measurement is 8, a 4, an x, and a 2. So remember, we're going to be doing whole times external equals whole times external. Okay, so for this one, the whole is going to be 8 plus 4, which gives me 12. And for this one, it's going to be x plus 2. So when I go to do this one, I'm going to do x times x plus 2. And for the red, it's just going to be 4 times 12. I'm going to distribute, and I get x squared plus 2x equals 48. I now need to get this in standard form so I can factor it. So I'm going to subtract 48, and I get x squared plus 2x minus 48 equals 0. I need now to find two numbers that will multiply and give me negative 48, but the same two numbers who, when I add them, I get positive 2. So what are two numbers that'll multiply to give me 48? That'll give me a 2. 8 and 6. Okay, and notice I'm going to have a negative on 1 because I need to be able to subtract, and I need a negative 48. All right, now that you found the two factors, now, if it just said factor, we would be done. But it's asking you to find the value of x, so you have to set each one of these equal to 0 and solve. So add 6. So one of my answers is positive 6, and the other answer is negative 8. Again, I don't want a negative side length, so I'm throwing this one out, and my only answer here is x equals 6. I can't have a negative segment. So you may encounter some of these in the homework, and you will have to factor them. But you remember how to factor? Coming back to you a little bit. Know that they start off Algebra 2 with this. You're going to get crazy fractional expressions that you have to factor and then cross things out. It was usually taught to you around this time of the year. This is where I think the Algebra 1 class is hitting it, the honors class, where they're solving the rational stuff and adding and subtracting. All right, so anybody need to see some more factoring practice, or are we good on this? Good?